Hello everyone, and before I begin presenting, I want to preface this by saying this is a team multimedia presentation that me and 3 other students made for our AP seminar class. So normally this would be presented by 4 people in total. And yes, all the research, everything in here, this presentation was made by me and my 3 other teammates, except we did use a template. Anyway, let's get right into it. Hello everyone, and today we will be presenting how early detection is the key to combating cancer. This chart shows what people died from globally in 2019. The second biggest cause of death, responsible for around 18%, was cancer, which means that on average, 27,600 people die from it each day. In this presentation, we are going to talk about what cancer is, what are its current treatments, why exactly is it so hard to cure cancer, our ideal solution, and then finish off with a few parting words. Well, what exactly is cancer, and how can we currently treat it? Cancer is a disease where cells ignore the body's signals to die off. Accumulations of these cells are called tumors. Cancerous tumors are characterized by their ability to metastasize, which basically means that the tumor spreads to or invades other parts of the body, sometimes very far from the place of origin. Normal cells do not do this because they die off once they come into contact with the surrounding cells, but cancer will uncontrollably grow and spread to other parts of the body. This is a problem because cancer cells do not function like normal cells, and they steal vital resources. This can cause vital tissues and organs to lose function. Cancer can be caused by environmental factors such as radiation and chemical carcinogen, and also lifestyle factors like aging, nutrition, and obesity, along with genetic predisposition. Now we know what cancer is and why it's dangerous. Let's talk about its current treatments. Starting off, we have a localized ones. These are therapies specifically directed at a tumor or a particular area of the body where cancer is present. These treatments target the cancerous cells in a confined region without affecting the rest of the body, the first type of which is surgery. According to the American Cancer Society, it involves the removal of tumors and sometimes surrounding tissues. This method is particularly effective for early-stage cancers that are localized and haven't metastasized. In such cases, surgery is often curative, aiming to completely eliminate the cancer and prevent it from returning. Another type of localized treatment is radiation therapy. According to the National Cancer Institute, radiation therapy uses electromagnetic waves to kill cancer cells. It does so by damaging their DNA. And as you may have already guessed, radiation also hurts healthy cells, creating a lifetime limit to how much radiation therapy a person can receive. Next up, we have systemic treatments. These are therapies that target cancer cells throughout the body. They circulate through the bloodstream to reach and treat cancer cells wherever they may be. The first type is chemotherapy, which according to the National Cancer Institute, chemotherapy is the use of strong drugs to kill rapidly dividing cells. Because cancer grows faster than healthy cells, it suffers the most damage from chemotherapy. However, the downside to this treatment is that because it works throughout the body, it can cause many side effects, such as hair loss and nausea. The second type of systemic treatment is immunotherapy. It strengthens the immune system to fight the disease from within. According to Dr. Remraoui, immunotherapy works by enabling the immune system to recognize and attack cancer cells, which often evade detection by the body's natural defenses. One common type of immunotherapy involves drugs known as checkpoint inhibitors. These drugs block proteins that cancer cells use to hide from the immune system, allowing immune cells to target and destroy them, particularly for cancers that are aggressive or have metastasized. Now that we've talked about the current cancer treatments, why is it still difficult to treat cancer? Well, these are the 5-year cancer survival rates for different stages of cancer. As you can see, the survival rate for stage 1, where the tumor is small and localized, is very high. In contrast, the survival rate for stage 4, where the tumor has spread to distant parts of the body from its origin, only has a survival rate of around 13%. As previously stated, treating late-stage cancer is difficult, so let's talk about exactly what factors affect their treatment. According to Dr. Lee and Dr. Swanton, there are 3 main ones. The first being if the cancer metastasizes, making it difficult to target effectively. Another is tumor heterogeneity, in which tumors are made up of diverse cancer cell types, each responding differently to treatment, which complicates the effectiveness of therapies. Finally, there's treatment resistance, where cancer cells adapt over time and become less responsive to drugs, reducing the success of long-term treatment. Not only that, but there are limitations to the treatments we talked about previously. Localized treatments can't fully treat cancer because they only target specific areas of the body, making them ineffective if the cancer has metastasized. Systemic treatments cannot fully treat cancer because while they target cancer cells throughout the body, they also harm healthy cells, leading to severe side effects like organ damage and, in some cases, death from the drugs. So, treating late-stage cancer is challenging, but early detection greatly improves treatability and survival rates, making early diagnosis our key solution to avoid late-stage treatment altogether. The first method is regular screening programs. Regular screening programs are where individuals with a high risk of cancer are recommended to undergo regular screening through methods such as low-dose CT scans. This method is effective because it targets specifically high-risk individuals, such as long-term smokers for lung cancer or old-age women for breast cancer. Also, since specifically high-risk individuals are targeted, it's less likely that medical resources are being wasted on someone who is less likely to actually have cancer. However, this method also has few downsides. The first being that it doesn't account for anyone else, meaning that for the general population, the risk of undetected cancer remains about the same. Also, undergoing several screening tests over many years can introduce unwanted side effects, such as radiation damage from repeated CT scans that can ironically increase the risk of cancer. The biggest issue with regular screening programs, though, are false positives. By undergoing several cancer screening tests over many years, the chance of a false positive is exponentially increased. Next, let's talk about liquid biopsy tests. Liquid biopsy tests are tests that can analyze your blood in order to try and detect possible cancer cells within. This method is effective because it only requires a simple blood draw. Additionally, since it analyzes your blood for any cancer cells, it can detect many different types of cancers. In fact, Grail's MCED liquid biopsy test can detect and identify more than 50 different types of cancer, 70% of which do not currently have recommended screening tests. This flexibility makes this test very viable for anyone who wants to generally check for any type of cancer they may have. However, this method also has some very outstanding issues. The first of which being that it is very expensive and very experimental. Even if you have the hundreds or thousands of dollars needed to fork over for a liquid biopsy test, it's unlikely you will be able to receive this test unless specifically referred to by a doctor or other specialist. Also, since liquid biopsies are still very experimental, they have very low accuracy rates. According to a study on the accuracy of different liquid biopsy tests, a DX-Cover cancer liquid biopsy test has two options, with the former having a 58% specificity, meaning that someone without cancer has more than a 40% chance of getting a false positive, with the latter having around a 59% sensitivity, meaning that someone with cancer has more than a 40% chance of it going undetected. But how can we solve these drawbacks within our current solutions of early cancer detection? Well, that is with artificial intelligence. Making its way into seemingly every industry, AI can play a crucial role in diagnosing cancer early. According to the National Cancer Institute, AI's ability to process huge amounts of data could make a breakthrough in cancer diagnosis. Even if AI won't be able to diagnose on its own, it could still be used as a tool for less experienced doctors. The efficiency AI can bring to cancer detection could also solve issues relating to the volume and time of the tests. After all, if more people start getting tested for cancer, someone will need to process all of the tests. The downside to using AI is that it requires a lot of storage and power, making this solution harder to get into. However, you can start giving people with higher risk for cancer more tests, but you can't buy half of an AI. Here are a few examples of AI being used in our world right now. According to a 2024 article from the Harvard Gazette, researchers at Harvard Medical School developed an AI that could identify cancer with a 94% success rate. A 2024 study from Mansoura University in Egypt found that AI could be used in early detection with a 99.45% success rate in finding cancer and a 93.94% success rate in distinguishing the specific type of cancer. The following image highlights key areas in MRI scans that an AI model used to identify tumors. The bright spots on the scans show where the AI focuses the most, helping it recognize patterns linked to brain tumors. This could make diagnosing cancer faster and more accurate, leading to better and more personalized treatments. AI in cancer is significant because not only will it be much faster at diagnosing cancer, leading to earlier detection, but it also will be much more cost effective after the upfront cost. So, in conclusion, late-stage cancer is difficult to treat because of metastasis, cell heterogeneity, and treatment resistance. And there are also numerous limitations in our current treatment methods that restrict their effectiveness in late-stage cancer. The two diagnosis methods we presented are regular screening and liquid biopsy, but they each have their own drawbacks. This brings us to our ideal solution: artificial intelligence in diagnosis. Integrating AI into cancer diagnosis transforms detection with faster and more accurate results. Not only that, but it can be very cost-effective and can reduce the time required for diagnosis. Thank you for listening, and here are our references.